have two captivating talks lined up to inspire you and spark your curiosity. So this session promises to leave you with a renewed sense of inspiration and a thirst for knowledge. So get ready to be engaged, enlightened, and motivated. So as the very first speaker, we have Dr. Nadeeka Basnayake. Dr. Nadeeka is a senior lecturer at the Department of Statistics, University of Colombo, possessing more than 10 years of experience in academia. Her main teaching areas include data science, statistical programming, and applied time series. She was awarded her PhD in 2019 from the Department of Statistics, University of Colombo, via a collaboration between Western Sydney University, Australia. She has made several important contributions to the field of data science through her PhD. A novel methodology to forecast short-term daily catchment flow of Kotmale reservoir in Sri Lanka, a novel algorithm that reduces the adverse effect of non-stationary nature to a nonlinear model, a novel plot that can be used for model selection more effectively than the usual error analysis, and a modified error measure that reduces the effect of extreme observations to the model structure identification task in artificial neural network modeling are the key findings of her PhD work. She received her bachelor's degree majoring in statistics with computer science from the Department of Statistics, University of Colombo, and she holds a master's in financial economics. Her current areas of research include machine learning, statistical modeling, and wavelet analysis. So with great pleasure, I would now invite Dr. Nadeeka Basnayake, who is also one of my beloved lecturers at the university, for the very first lightning talk. She'll be speaking on wavelet transformation, a useful tool for time-related data. Over to you, madam.
Thank you, Soumya. So, am I audible?
Yes, you're audible.
Okay, so hi, everybody. Thank you for that kind introduction as well. And like, it's a privilege and an honor to be a part of this conference. So the title of my talk today is Wavelet Transformation, a useful tool for time-related data. Yeah, so when talking about transforming a time series, I hope all of you have heard about Fourier transform. So Fourier transform is a mathematical transform that can express a function of time that is a time series as a function of frequency. So when it comes to time series data, the most important property is whether a series is stationary or not, right? So if the series is kind of stationary, the frequency component of the series does not change over time. Like it kind of have similar components throughout the series. Therefore, for a stationary time series, the need of knowing at what time a certain frequency component exists is not important. So that for stationary time series, again, the important characteristics can be determined using Fourier transform. But on the other hand, like usually the practical time series are complex and noisy and non-stationary, like strongly non-stationary sometimes. So for those series, Fourier transformation will not be the solution. So we need an alternative transformation that has resolution in both time domain as well as frequency domain. So that's where wavelet transformation came into play. So the question might arise, why do we need frequency domain? Why not just have it the time series as it is in the time domain? So the answer for that question is the information which cannot be observed in the time domain can be observed in the frequency domain. So that's why we go for such transformation as having information in both time and frequency domains is very useful. So then what is wavelet transformation now? So wavelet transformation, I mean, the origin actually is in the field of physics and engineering, but it's recently migrated to data science due to the effectiveness in the concept when handling practical situations. So out of the variety of applications of wavelet transformation, I'll be focusing on its usability in handling time-related data. Yeah. So wavelet transformation is a mathematical transformation applied to obtain hidden information, which is not readily available in the raw signal or series. So by definition, a wavelet is a small wave localized in time with finite length, right? So here's an example of a wavelet, Molet wavelet, named after the person who has first discovered this specific pattern of the small wave. So apart from that, there are many other wavelets as well. You give it a special name, mother wavelet functions. So each type of wavelet has a different shape, different different smoothness, different compactness, and also these are being used for different purposes. So here are actually some such types of mother wavelet functions: Simlet, Daubechies, Molet, Mexican hat, and Mayer. So here again, only a few out of the options available. So now wavelets actually can handle high and low frequencies by rescaling. So it stretches into a long function that is wide windows to measure movements with low frequency, and it compresses into short functions that is narrow windows to capture high frequency movements. So you get to denote different scales using different orders. Right here in this slide, you can see different orders of Daubechies wavelet, dB2, dB3, up to dB10. So Daubechies wavelet of lower orders are for low frequencies and higher orders are for higher frequencies. So the first step in doing wavelet transformation is identifying the most appropriate mother wavelet function. So for that, you need to consider the ratio between wavelet energy to Shannon entropy. Right? So this ratio gives you the extent to which given mother wavelet, given whatever the selected mother wavelet suits, the extent to which that mother wavelet suits a particular time series. So this graph is drawn for catchment flow time series to Kotmale reservoir in Sri Lanka, and it clearly indicates that Biospline's wavelet of order 3.1 best suits that particular catchment flow series. So once you identify the most appropriate mother wavelet, the next step is wavelet translation. So in this step, you go through the whole time series with the specified mother wavelet function, which is denoted in red, mapping it at various locations of the original time series. So this is how it moves on in the original time series. So fast wavelet transformation algorithm is an algorithm designed to do discrete wavelet transformation. And in the practical execution, the signal or the series passes through two filters, high pass filter and low pass filter. So the resulted output from the high pass filter is separated first, and the remainder is further processed to the next level. So this process is repeated until the required number of subseries are obtained. So high-pass filters output the detail coefficients, whereas low-pass filters output the approximation coefficient. So this filtering procedure can be continued until the required number of decompositions one would want to have. So this is again an illustration of how that happens for a particular time series. So in your right-hand side, you can see the high frequency components are being separated, green series. And we give them a special name, detail coefficients. You denote them in capital D. So in the left-hand side, you have, that is series in blue. Those are the low frequency components. We name them as approximation coefficients. You denote them by capital A. So if we stop at 3 levels of decomposition, the transform series will be A3 plus D3 plus D2 plus D1. So now after transforming, these original series can be replaced by these 4 series. This is at level 3. So this way, we can get a very useful set of decompositions of a time series capturing information at various resolution levels. So in red here, you can see the original series followed by the transformed sub-series. So this discrete wavelet transformation has the ability to capture information of the time series at a different resolution levels. So you call it multi-resolution property. So this is ideal for complex, noisy, and non-stationary time series. So this golden property can be used like in almost every application related to time series data. It can be clustering, classification, anomaly detection, and even forecasting. So we actually don't have time this is a short talk, so we don't have time to discuss each and every application separately here today. So, but I thought to grab your attention to the area of forecasting using wavelet transformation and neural nets. So as we also have carried out research into this particular area. When forecasting a time series data, it's always hard to deal with that nature because you get to deal with complex, non-stationary data. So, various research has been conducted to overcome this issue of the complexity through data segmentation. Because even a very well-trained neural net is reported with less performance when the data is noisy and non-stationary. So for this, the scientifically proven way of handling the issue is transforming the inputs of the ANN, doing a proper transformation and input those transformed data into the ANN. So here I'm extracting a very few researchers conducted in that manner, right? In other words, using wavelet transformed data as inputs to the neural net model. So you give them a special name, wavelet neural network. So model architecture in each of these applications is not the same, but the core principle is to use wavelet transformed subseries as input vectors so that transformation at various levels, various resolution levels can be fed into the model fitting task. So to list a very few set of applications, we have monthly river flow forecast using the previous 12 months flow data, daily reservoir inflow forecast using daily rainfall, previous inflow values and stream flow data, rainfall forecast using decomposed subseries of antecedent values of rainfall. So comparisons in all of these studies have confirmed that the Wavelet neural net hybrid models are resulted with much better performance than the single ANN. So this is actually a novel algorithm created as a contribution of PhD work done by myself under the supervision of Dr. Dilhari Artigala from University of Colombo and Dr. Limon Lianage from Western Sydney Uni and Professor Nandalal from University of Peradeniya. This actually consists of so many other detailed steps and phases, but here I'm trying to bring out the core of it. So we used various different expert neural net models to different subseries and obtain an aggregate forecast instead of a single forecast. So in this method, you need to like careful attention need to be paid to find the proper way of transforming the time series that is under the study, and also more importantly, the number of subseries to be used. In other words, number of submodels to be considered. So in this illustration, I have used 6 models, but ideally it can be reduced further in order to, if you want to reduce the complexity of the model, or you can do it in the other way around as well. You can even increase the number of models. So, however, in our application to model the daily catchment flow data, this particular approach was reported with much increased performance than the other approaches, which didn't consider wavelet transformation. Yeah, so here I have listed the main advantages of the algorithm proposed by us in brief. So the data are divided horizontally without losing the time domain information. Separate expert models are built for each subseries, and the final model captures information at various resolution levels, thus extracting hidden features. So here, then we come to the end of this talk with this final note. So wavelet transformation capture information at various resolution levels, thus extracting hidden features. And wavelet transformation can handle complex, noisy, and non-stationary nature of time series data, which makes it a good preprocessor for various applications such as clustering, classification, anomaly detection, and forecasting. So these are some of the references I have used for this presentation. And thank you. So so now I'm open to questions if you have any.
Yes, madam. So we wholeheartedly thank you for delivering an incredibly informative speech that has enlightened us and left a lasting impact. So now the floor is again